Hello, this is Steve French. I'll be presenting today on the SMB3.1.1 POSIX, or Linux extensions as we prefer to call it, for the Linux client, and I'll give you an update on progress. It's been a very exciting year. Earlier I presented on the more general changes to the Linux client, and Matachi, one of our team, is also here presenting on some of the interesting debug tools, and Volker will be presenting on the status of the POSIX Linux extensions in Samba server. So I always want to begin reminding people that these are my opinions, not necessarily those of my employer, Microsoft. And for those who haven't been to earlier sambaXPs and met me, I'm the original author and maintainer of the Linux CIFS client, now SMB3.1.1, all the way down to old dialects like CIFS. I'm also co-maintainer of the Linux kernel server with Namj. The kernel server is called ksmbd. Jim McDonough and I, many years ago, created the net utility for Samba. So currently I work for Microsoft, working on Azure Storage, but I focus on the Linux client accessing the largest file server in the world, XSMB. So today I'll give you a kind of an overview of what the POSIX problem is, what POSIX is, and talk a little bit about what Linux versus POSIX means in terms of these protocol requirements. Then go through the current status of where the Linux client is today in implementation. We made a lot of progress at the Plugfest last year, the test event last year in Santa Clara. So that was fantastic because we were able to really solidify the Linux compatibility mounting to Samba and to ksmbd. So I'll go through the current status, and then I'll give you kind of an overview of what the extensions are and some examples, and then talk about what's next. And hopefully at the end we'll have some time for questions as well. Now, I've mentioned this before, but I want to make sure we keep mentioning it. POSIX is not exactly the same thing as Linux. Back in 1988, POSIX was kind of based on BSD Unix and System 5 Unix. It was later standardized by the Austin Group and IEEE, and I think you'll see that the documents are still out there, but it really hasn't changed much in a long time, at least the system calls we're talking about. Now, Linux, interestingly enough, was created after POSIX, 1991, and it really gained a lot in popularity when IBM and others really increased support for it 10 years later. So the interesting thing about Linux is that it has a syscall API, set of APIs, and it is stable, but it is way bigger than POSIX, and it keeps growing. And Linux promises not to break the syscalls by removing syscalls that were added that user space could depend on, but Linux is a heck of a lot bigger than POSIX, and it solves a lot of problems that POSIX didn't even dream about back in the 90s. Now, interestingly, SMB, the original dialect, predates POSIX, but as you might guess, HP and Sun and others created dialects for SMB to support POSIX, and then that was standardized work that Jeremy Allison and I and others did with the Storage Network Industry Association. Was standardized about 20 some years ago for SMB1. But years later, the protocol kept evolving. SMB2, SMB2.1, SMB3, then SMB3.1.1. And when SMB3.1.1 was created, it was really obvious that there was a need to create an equivalent for the SMB1 POSIX extensions to allow excellent Linux compatibility when you're mounting from Linux to a SMB server. Now, I've mentioned this before, but I kind of want to hammer this point home. Linux keeps growing. Now, I checked a couple days ago in 6.15, which release candidate was just shipped yesterday. 615 RC1 was just shipped yesterday. In 615 even, they added new syscall for file systems. Now it seems crazy, but there are 231 file system related system calls for Linux. That's probably, about as many as all of POSIX had, right? This is kind of a crazy world where the file system API alone of Linux has such a huge number of syscalls. But it's not just syscalls. It's also ioctls. It's also fsctls. So here are some examples just from the last year. So it keeps growing. Now, what does that mean for us? It means we've got our work cut out for us. If we want to be perfect and we want the SMB mounts to look like a local mount and support all these features, we're going to have to be careful. And now some of them, like get UUID, looks like we can emulate. Get FSpath, possible. But we have to look at these one at a time and make sure that either they already work or figure out what's needed to make them work. Now, if you look at, go back another year or two, 10 more examples. The file system API in Linux keeps growing, and a lot of these are harmless and don't need any changes in sys.ko, or certainly not in the protocol, but others we need to look at carefully. So this is a moving target. Linux is going to continue to evolve. Lots of wonderful security features, lots of interesting performance features keep being added. Now, I've mentioned this before. We got 800 syscalls, 500 are documented, 231 in the FS layer. Let's look through all 231. Make sure, and by the way, I have a typo there. It's 615 RC1, not 614 RC1. And, POSIX was a much easier game. Now, what's the goal here? I think it's pretty simple. Let's look what it says there. Fast, safe, secure. We want to be the standard, easy, general purpose way you access file data, whether that's in the largest server in the world, XSMB, whether it's in on-premises, virtualized, whether it's in some small embedded device. We want to make sure that our performance is good. We enhance the metadata and data caching and use multi-channel and these amazing features of SMB3.1.1 well. We want to make sure that we improve performance for a very broad set of workloads, for slow servers, fast servers, servers with lots of NICs, servers with RDMA, servers with slow NICs. But we also want to make sure we support these new Linux features. We don't really want apps to have to think, oh, am I running on a NFS mount or an SMB mount, we want them just to think an SMB mount is kind of like a local mount. We don't want to have hacks to work around missing features. Now, what's one way to do that? We can run the standard file system tests. In Linux, the file system tests are called XFS tests. These standard file system tests test a very wide variety of features. And, these new fsctls, new flags, we need to be running these every day, and we are. But we need to keep pushing to see what additional flags need to be emulated to make sure we're not missing things. And as Linux evolves, let's keep adding features to the kernel client and Samba and ksmbd and continue to extend the protocol if needed, but in a lot of cases, these can just be emulated. Now, what's the biggest requirement? We got to make it safe and secure. There's a lot of great talks here at SambaXP about improved security. SMB3.1.1 handles that very nicely with GSS API, and I know there's lots of great discussions about IA curb and um, and new auth mechanisms, but we also need to talk about making it the most safe, stable thing out there. So let's keep up the test automation. The KDevOps that is popular in the Linux file system world. KDevOps automation runs regularly, again, stable with SMB. We have a Lisa test framework we'll talk about later, and also the build bot that I run daily for checking against a wide variety of servers. Let's make it fast, let's make it safe, let's make it secure, because we want this to be the easy way you access the widest variety of servers. So what's the status? Okay, net it out. Multiple clients, multiple servers now support these extensions. We added the support on the client back 5 years ago, but it wasn't until about 3.5 years ago that it was improved enough really to try in production. But there were some really important fixes added even late 2024 in the 6.12 kernel. Now, these have been backported to earlier kernels, and that's thanks to some good work by Volker and Ralph and others at the SNIA Storage Developer Conference and Test Event, for example. Now, for a better update on the Samba server, see Volker's talk that's following this. Also remember that Samba's client tooling, the FTP-like tool SMB client, also supports these extensions. ksmbd, Namjae's Linux kernel server, also supports the POSIX extensions, and there's also some third-party servers. We've tested with these at various test events over the last 3 and 4 years. Now, are they production ready? That's a very good question. Technically, we mark them when you mount. We warn that they're experimental. We log that. I think we're going to remove that warning, though, as soon as we update our test automation. One of the problems we've had recently is really trying to make our test automation better and better. And there's multiple things in progress for that I'll talk about later. But now that Samba 4.22 is out with good support for these POSIX extensions, we need to test the heck out of it, not just to ksmbd, but also to Samba. And that, it is as simple as adding Linux or POSIX to the mount command. You can see, by the way, here on the mount, what happens when you mount with Linux versus no Linux. If you look at the mount to no POSIX mount, you'll see the no Unix circled in the mount options after the mount completes. If you look at the one that was mounted to the POSIX mount with the Linux mount option, or equivalently POSIX mount option, you see how it says POSIX in the mount option. You can see from that it was successful at negotiating the POSIX extensions. Now, this is getting a lot better. And I think that we definitely see workloads where there's a big advantage to running with POSIX mounts, the POSIX mount option. Now, one reason we're fairly confident about it is the POSIX extensions were intentionally made very simple. We have a negotiate context, you can see here. Basically, at protocol negotiation time, we tell the server we support POSIX. If it ignores it or says no, we don't use POSIX extensions. If in the future we have to add a new version of the POSIX extensions to address some new features coming up, well, it's very easy. We add in that reserve section you see at the end, we'll be adding another ID that indicates the new version type. But currently we haven't needed to. We've been able to use the one that we defined more than 4 years ago. What else did we add? Well, we added 2 info levels. That's pretty darn simple. One to query file information and one to query file system information. And we added an open context that optionally can be sent on open. You can see that create context in this Wireshark trace. And notice that Wireshark has long had support for these extensions and can decode them nicely. So basically, these POSIX extensions are more safe than you might think. Now, let's talk about why it matters and why, there are many cases where you might actually be wanting to use it now. Now, look at StatFS. I have two examples here. One to the no POSIX mount, where you're not mounting with POSIX, and one where you are. And compare that with the bottom, where you see what the actual directory on the server looks like. Notice we get the block size right with POSIX. We get the fundamental block size right. We get the total blocks right, free and available blocks right. Total number of inodes are reported, number of free is reported. Much more accurate info than mounting by default without POSIX. So once again, the top one is without the POSIX extensions, the middle one is with the POSIX, and the bottom is the local share. And you can see that we mirror pretty exactly what the local share is. The difference is the file system UUID, the file system ID is different, but pretty much it's the same. And of course, we don't report that it's XFS in the SMB example because we're on an SMB mount. Now, that was an example, FS info. What about file info? With POSIX, the number of links is reported accurately. The mode is reported accurately. The owner is reported accurately. Now notice that the POSIX UID, the owner UID, is returned for users that don't have an existing SID. Otherwise, they do an upcall for that. Now, notice that there is one difference that you see between the local and remote mount, even with POSIX, and that is that the IO block size. For local file systems, they recommend the small 4K IO block size. Obviously, for network mounts, we default to an R size that's much bigger, an IO block size of 1 megabyte. But I think you'll notice here that, once again, look at no POSIX versus POSIX. You'll see that the mode bits are correct in the POSIX example, but not in the without POSIX example. The owner fields, the link count, in other words, in this particular case, the link count represents how many files are in that directory, are reported correctly. So this is a big improvement. So this is file info. We talked about file system info, file info. Let's talk about another example, special file support. Now this went through some changes last year. Ralph and Volker and I and others discussed this. Now, the nice thing about this is that even without POSIX extensions, special files are now reported better by Samba and recognized by the Linux client. And with the POSIX extensions, not just that, but the size of symlinks is reported correctly, and the mode bits and owner are accurate as well. So notice that we can report block files, char files, FIFOs, hard links, symlinks, all that looks great. And even in the case of not mounting with POSIX, these special files can be reported by Samba and recognized by the client. So I think that that's a big advantage. But also notice the owner information and mode bits are reported correctly with POSIX. But if you don't mount with POSIX, you won't get that. Now, what's another example? This was fixed not that long ago, last year. Changing the mode works fine with POSIX extensions. But if you're going to do a chmod without the Linux or POSIX mount option, you need to mount with syscalls. And syscalls emulates the ACL based on, emulates the mode bits based on the server ACL. And in the case of syscalls, it's often used with no perm mount option because in the case of syscalls, you're already evaluating it accurately on the server. So why do you want to have the client evaluate the permissions as well? An alternative is called mode from SID, and the mode from SID mount option stores in a special ACE, a special access control entry, mode bits that are emulated, that are ignored by the server but only honored by the client. And anyway, you can see here a great example. If I create a file and I look at the mode bits from the POSIX mount versus the not POSIX mount versus notice that the POSIX mount is reporting more active. Well, what if I do a chmod? If I do a chmod on the POSIX mount, in this case to 754, it works fine. Stat reports it as 754. If I do a chmod, in this case on the non-POSIX mount to 740, and do a stat of the non-POSIX mount file, it just uses the default 755. It doesn't report correctly the mode bits. So if you want chmod to work, sure, you can use syscalls, you can use mode from SID, but in a lot of cases it's a whole lot easier just to use the Linux or POSIX mount option. Now, what about other obvious features? If I remove a file that's open, well, I created a file here called delete file test. I made it stay open with that exec call you see there. And then I did cat proc fsfs open files to show you that the delete file test file is open. And then I do an RM of that file. Well, the RM says it works, but when I do an ls of that file, it shows the file delete file test still around in ls, even though it returns no such file or directory, which is kind of confusing. Now, if I close the file, I do exec ft, you can see there I close the file. Now there's no more no more file open. Yeah, at that point you see the file's gone. But it's kind of confusing when you're deleted the file because it stays around while it's still open, which is not what POSIX, POSIX hides it when it's deleted, even if it's still open. Now, what about with POSIX extension, with the POSIX mount option? Let's do the same test. Created a del file test file named del file test. I open it with that exec call. You can see that it's open with cat proc fsfs open files. And notice that RM worked, ls, file's gone. The file's still there. The file's still open, but it's gone. And then I close the file and the file's closed. So the end result of all this is that when you mount with POSIX, you don't have the risk that somebody's going to be confused because the file is still showing up in ls and stat, even though it's been deleted. In the non-POSIX example, when you're not mounting with the POSIX extensions, you have to, the RM will work of that open file, but it won't actually be deleted from the namespace until you close it, where behavior is much more POSIX compatible when you mount with the Linux mount option. Now, similarly, rename of an open file or onto an open file, it works great. You can see I create a file named rename open file test. I open that file and then you can now see it open. Now I try to move that file onto another one and it worked fine. So rename of open files works exactly as expected with the POSIX mount option. There are cases where it can work without POSIX, but not all cases. So with the POSIX extensions, it always works. Without POSIX, it only sometimes works. This case of renaming an open file onto another file or renaming a file onto an open file. What about case sensitivity? Well, even building the kernel requires this, right? You have to have, there are multiple files with the same name that just differ in case. Here's some great examples, right? Look at, works great with POSIX. Without POSIX, tell you what, it's kind of annoying if you think you're opening the lowercase version of it and you actually open the uppercase version of it. You don't know which one you're opening when you have when you don't mount with POSIX. With POSIX, it handles case sensitivity fine, and also notice it handles the mode bits and owner, and it handles these fine. So what else? Well, the POSIX extensions help you with advisory locks. Now, Jeremy Allison has mentioned many times that kind of POSIX advisory locks are broken by design, but there are apps that depend on them. And if you want advisory locks, you need to mount with Linux. And there are other features that work with or without the POSIX extensions. A good example is various flavors of fallocate, finsert, for example, query allocated ranges, that sort of thing. And various types of sparse file support work and can be emulated without POSIX. But these SMB POSIX extensions are a huge benefit for Linux compatibility, and I do recommend them in many use cases, especially to current Samba. Now, I talked a lot about Samba because we're at sambaXP. Is it just Samba? Is it just syscalls? Obviously not. It's also supported by ksmbd, the Linux kernel server, which I co-maintain with Namjay, and more. Now, here's an example I just pasted here of ksmbd. Now, notice that in this ksmbd example, they're not exposing symlinks by default. So when you're mounting to this, you may prefer to use mf symlinks as a mount option to handle mounting to ksmbd. But notice it handles the special files we talked about, block, character, FIFO. And notice it handles the mode bits. It handled the case sensitivity. You can see it on this picture here. It handles the owner, returning the owner and group owner correctly. So it's not just Samba server, it's also ksmbd and others. And I think I mentioned before, it's not just SMB client in the kernel, it's also SMB client, the user space Samba tool, and others. Now, what do we have to do still? Let's give some example to-dos. Now, today, if you do chown or group, if you want to change the owner or change the group, there's a couple of ways to do that. You can, with the POSIX extensions, we talked about how you do that, or you can upcall to get the SID of the user. And that's often done with the syscalls option. And you can look up the man page of sys.id-map for more information about how that's handled. You might want to, it may query from WinBind or SSSD information about, which UID corresponds to that SID. Or you can use the IDs from SID mount option, where the owner is not understood by the server. It's stored in a special access control entry that's ignored by the server. It's only seen by the client. And that's useful in cases sometimes with mode from SID and IDs from SID together, where only the client is evaluating permissions and the server is basically wide open. Now that's great, but there are probably cases where we need to make it easier to upcall to get the correct SID for the user when we're doing chown and group with the POSIX extensions, making that easier to do. Now, what are some other examples? There are some server-side examples we've talked about before. We could add, without even having to extend the protocol really, just add some optional FSCTLs. It turns out that I think NTFS supports some additional FSCTLs for handling sparse files. Those could be exposed someday, perhaps. One of the comments that David Howells, as the maintainer of the NetFS mapping layer, caching layer, has made multiple times is he would prefer if we could make some of the way we handle fallocate more atomic. Today, collapse range and insert range are kind of a multi-operation compound operation. Make it a little more reliable to make these fallocate. Fallocate has many options, but make some of these specific FSCTLs instead of a combination of FSCTLs. Another point that's been mentioned is that there are certain things like rename exchange and rename whiteout that shouldn't be too hard to be able to add as flags to the existing rename or add as a new FSCTL. Another thing that may be easy to do, there are cases where you may want to have an NFS server sitting on an SMB3.1.1 gateway, and in those cases you may want to open a file by inode number. That may be a minor improvement. Now, those may require server-side changes, new FSCTLs supported, but there are a lot of things that could improve our compatibility with Linux that don't really require any of this, that just require client changes. OTemp file can be emulated today. We got pretty far along in doing that. We're very close. CHAdder, supporting the immutable flag and the append-only flag, that should be doable. We may be able to, with just client-side changes, improve quota support to more natively support Linux quotas. Now, of course, we can do a lot of this through user space tools like SMB info, but when you want to do it through the standard Linux tools, it can help to have, it may require minor changes to the VFS in some cases. We talked about this, for example, for iNotify and FA Notify, which requires minor VFS changes because they don't call into the network file systems to tell them that they're supposed to be waiting on this event. So it would be a fairly minor change to properly handle iNotify, FA Notify. Now, we can still do this with private FSCTLs and with user space tools that we have in syscalls, but there are advantages to doing this the way the Linux apps do it. Another thing that's been discussed many times is it shouldn't be too hard to be able to emulate POSIX ACLs. POSIX ACLs are a subset of rich ACLs or Windows ACLs, SMB ACLs. SMB ACLs are a superset of POSIX ACLs. So they could be emulated. Now what's next? Well, testing, and more testing. I'm very glad we have a test event going on this week. And once again, this fall, there'll be most likely a test event at the Storage Developer Conference again. It's very important that we go one test at a time through XFS test, keep looking at the failures in detail. You can see this in the Samba wiki. The XFS testing CIFS page has a lot of information about how to set it up and some more detailed test results. Now, XFS test, I know it's a confusing name, but it's the standard Linux file system functional test suite, and there's no file system passes all of them. And there's a lot of file system optional features and some that only would make sense if you have a block device under you. But one at a time, we've been going through these tests, and minor features, minor extensions, we got to look at all possibilities to make sure we run all of them that are possible. Now, if we have to, we could add a new POSIX extension version. I don't think we have to. It'd be very easy to add a second UUID to the POSIX negotiate context, but I think that just a few additional FSCTLs and we could be there. Testing, more testing matters. It's critically important now. I want to take that warning out of the, when you mount with Linux or POSIX, I want to make sure you don't see that warning anymore. And we have this build bot that we run daily against a wide variety of servers, not just Windows, Azure, Samba, ksmbd. Now, this Samba with Linux extensions enabled target needs to be updated to more recent Samba 4.2. I actually did that today. The testnet list needs to be cleaned up and extended to add some additional now working tests. And I think I also may have found one or two problems. I was looking, for example, at clone range. Now, there's also a very promising new test automation feature that our India team's been working on called Lisa. And I'm very excited about that. It may make it easier. Currently, one of the problems we have with BuildBot, you really can't run it against old kernels. It's got to be sort of like 6.9 or 6.10 or later. It won't run against old kernels. but we need to run against stable. We need to run against 6.6 stable, the long-term stable. We'll need to be running against 6.12 long-term stable. And Lisa may help with that. Obviously, there's also KDevOps that's run by Google and many others, not just against stable kernels, but against current kernels. And I'm looking forward to them also adding more testing. Now, obviously, we'll focus on mainline. We'll focus on long-term stable 6.6 and 6.12. And the distros are doing a great job testing SMB3.1.1 against their specific distro kernels. But we really welcome any additional help, bug reports, feature requests, more testing. Testing matters. Here's an example of sort of what the build bot looks like. I'm running this daily. We're running against a wide variety of servers with lots of different config options, with multi-channel, without multi-channel, all kinds of different options. Right now, actually, this week, I've been working on improving multiple test targets for the POSIX extensions, not just to ksmbd, but also to Samba 4.22. Now, we run almost 300 file system tests in our main test group to a wide variety of servers, but our goal in the POSIX group is over time to run even more as we work through these tests one by one, because we may find minor things. I was looking, there's some swap file related tests we could fix. There's some fairly simple things that I was looking at this week that we could fix to add more tests that we can run. This is a huge priority, and I'd love additional help and suggestions on this. And the more testing, the better, because the POSIX extensions really are the future. This SMB3.1.1 is a fantastic protocol. And now that it's well supported to multiple servers and well tested, I'm really looking forward to seeing its use keep increasing. I think the future is very bright, and I look forward to hearing more of feedback from you all. And if you get a chance to talk with those and help those working on the co-located test event that's going on now, that would also be fantastic. And then in this fall, we'll continue to be testing with many different servers at the hopefully at the Storage Developer Conference as well. But the future is very bright, and thank you for your time.